Section 4.3, Weight and Weightlessness. So remember that when you stand on a scale, and so you step onto a scale, you push down on the scale, you compress the springs in the scale supports your weight, and by doing that, measures then how much the scale is holding you up. So imagine something, and you've all done this in terms of, you've all experienced this, but imagine that you're walking to an elevator and there's a scale in the elevator. You stand on the scale, and as the scale starts to move up, you get pulled down to the floor a little bit. The spring compresses just a little bit, and your weight will go up, only briefly, right as you start moving, right as you accelerate from not moving to moving. And then you feel normal right after that happens. You feel a similar thing right as the elevator stops. Now, if you were standing on the scale as the elevator went down, the spring actually stretches out just a little bit, and your weight becomes a little bit less. Right? And you can feel that again too as you're standing in the elevator. As the elevator starts to go down, you briefly feel a little less weight. And then once it's moving, everything kind of evens out again. Right? Now, you'll feel this every time you ride an elevator, but only as the elevator starts or stops moving. Most elevators try to avoid a constant speed with zero acceleration. You won't experience, in general, the constant speed. The constant speed feels normal to you. It's the accelerations that you experience, right as you start, right as you stop. Now, assume that you're in that elevator as it's going down, right? And right as it starts to go down, your weight gets a little bit lighter, but right as it starts to go down, the cable snaps, and the elevator just starts to fall. Well, now you and the elevator are both contained inside of the elevator, and both are falling to the ground. We know that everything that's in free fall falls at the same rate. So as the elevator falls and as you fall, you will not experience your weight. You will feel weightless. There is no force supporting you. Right? Gravity is still pulling you to the ground, otherwise you're not going to fall. But you don't feel your weight. You feel weightless. If you've ever been on, I believe it's the Tower of Terror at Disney World, right, or anything similar to that, any of those rides where they take you straight up and then drop you really quick, while you're sitting down, you experience weightlessness on those rides because you and the object that you're falling in are essentially all falling together at the same rate. As you do, in the Tower of Terror, you'll float up a little bit. Same thing with those other things, where I put the shoulder straps over you. You'll float up just a little bit. You feel weightless when you drop. This is the same type of weightlessness that astronauts experience. Astronauts inside of the space station or inside of a shuttle are constantly falling without a support force. And we're going to talk about that more in a bit, but this is important to know because it is something that everyone gets wrong. Gravity is all over the place. There is gravity above the Earth's atmosphere. Okay? There is gravity in space. Astronauts do not float because there is no gravity. There is gravity in space. In fact, without gravity, they wouldn't float. They wouldn't experience weightlessness. I'm not exactly sure what would happen because I can't imagine gravity not being there, but gravity is everywhere. And a lack of gravity is not what causes astronauts to float. For more information on this, watch the couple of other videos that are in this section.